And our next topic is meaning of differentiability at a point. Now, what do we mean by differentiability of a function at a given point? Remember, in the earlier episodes, continuity of functions, in the episode 1 and 2, I had explained to you that a function is said to be continuous at a point if and only the limit of the given function is equal to the value of the given function at that point. And you must have also noticed that in case of a continuous function, if we draw the graph of a continuous function, then there was no jump or hole or any break in the graph of that function. Or in other words, we can draw the graph of a continuous function in a single stroke or without lifting the pen or pencil from the plane of the paper. And now in the same manner, let's study what's the geometric significance of differentiation, or what exactly does it mean when we say that a function f of x is differentiable at the point x equal to c. Okay, let's take a function f of x and now let's draw its graph. And for that, let's first draw its x-axis and now y-axis where O is the origin. And for the given function f of x, suppose its graph is in a curved shape, and also suppose the function f of x is defined in an open interval a to b. And now let's take R as any point whose the x coordinate is c and y coordinate is f of c, and let s and t be another 2 points on that function. Here you can see s is at the left hand side of point R and t is at the right hand side of R, and the coordinates of s are, its x coordinates are c minus h, and y coordinate is f c minus h. And also for the point t, the x coordinate is c plus h and the y coordinate is f c plus h. And now if I ask you, now what's the slope of the chord rt? And now you know what's the slope of a chord in this right angle triangle. Now slope of the chord is equal to perpendicular upon base, and in this case the perpendicular is equal to the y coordinate, and which is equal to f of c plus h minus f of c, and the value of base is equal to the difference of its x coordinate, which is equal to x coordinate is equal to c plus h minus c, and which is equal to h. So that means the slope of the chord tr is equal to f of c plus h minus f of c upon h. And in the same manner, what's the slope of the chord SR? And here again, the slope is equal to the ratio of its y coordinates and its x coordinate, and which in this case is equal to f of c minus h minus f of c divided by minus h. And now, if we keep on decreasing this interval h, now as we decrease the value of h, or the gap between the point R, T and the point R and S, then you will find the size of this chord will become smaller and smaller, and if we further keep on decreasing it, then a time will come then instead of being a chord, it will reduce to a straight line. And what is that straight line? If you remember, if we draw a line at the point R which passes through the point R or just touches the point R, then that line is called as the tangent at the point R. And what do we understand from this? Or in other words, you can also say when the point S and the point T approach to the point R, then in that case, the slope of these chords or the slope of the chord SR and the chord TR becomes equal to the tangent at the point R. Or in other words, the tangent to the given function f of x at the point R is the limiting position of the chord TR and the chord SR. And also when point S and point T approach to point R, then in that case the slope at left hand side and the slope at right hand side both become equal to the slope of the tangent at that point. So we say that the function f of x is differentiable at the point x equal to c if and only limit h approaches 0 f of c minus h minus f of c upon minus h is equal to limit h approaches 0 f of c plus h minus f of c upon h. Or in other words, f of x is said to be differentiable at the point R if and only there exists a unique tangent at the point R. And what if the point R we are talking about in the given function is the corner point? And now if it's a corner point, then you can clearly see its left hand limit will not be equal to its right hand limit. So that also means that for the corner points or for the end points, given function is not differentiable at that point. So in case of a differential function, the endpoints are not included in the function.